Good morning, students. Today we are discussing about the topic of problem definition, flowcharts, and developing algorithms. This is from the first unit. So here we go that introduction to the problem definition. So here the problem definition is the crucial step in any problem solving process. Is first to be identify the what is problem and where the solution is. It involves identify the core issues and understanding its context. There are 6 steps of problem solving process, and clear problem definition helps to guide the development of effective solution. So the clearness of the problem definition, what's the problem is identified, it is the development of we give a effective solution. The next is importance of problem definition. So here we're discussing what is the problem definition importance. A well-defined problem can lead to a innovative solutions. So here we get a what is the problem definition. We gave innovative solutions to clearly, and we give output effectively, and it minimizes the risk of addressing symptoms rather than the root causes. So we identify the problem, what's the problem is, and where is the perfect solution, and where the correct route is. To it minimize the risk of addressing, and it clarify the problem definition, enhances communication among stakeholders. So we are addressing that the problem, what's the problem is raising. So it clarify the problem definition, so where it starts and where it exits. So what's the exact solution for that problem is. So next one, elements of problem definition. The problem statement should be concise and clear. So a problem, that problem statement is must be clear. The next is a key factors include stakeholders, objectives, and constraints. So that key factors include a stakeholder, so we get a key factors in that particular problem, and what we are discussing about the solution about that problem, objectives and constraints, what they are need perfect solutions. And a strong problem definition sets the stage for successful analysis and resolutions. So we what when we get the perfect successful analysis from the problem, that what we have, we give the perfect solution for that problem. Next one, it's introducing to the flow charts. So here now itself we be discussing about the what is the problem and problem solutions. So that problem we identify and analyze what's the problem and where it starts and causes for the problem. Here we implement the solution through the flowcharts in our computer language. So here flowcharts are visual representation of process or systems. Here we observe different shapes. We observe here at right side of the diagram, that is rectangular, triangular. So they help to mapping out the sequence of steps involved in the task. So it indicates to perform computer step by step process, what will exist first and what second, and it gives instructions to the computers through the conditioning formats, or if else, greater than or less than. Flowcharts can simplify the complex process, making them easier to understand. So here we identify the which symbol is to conditioning format, and which where it starts and where it exists. So here we indicate the different sizes, different shapes we indicates in the flow charts. What's the step we execute there. Next, components of a flow chart. It stands as symbols include ovals for start. Here we observed ovals. Ovals for start the flowcharts. And next, rectangular for process and diamond for decision. So here we discuss the conditions true or false, yes or no, and greater than or equal to. Here we perform the decisions. For that it takes the diamond symbol, and rectangular for process, that we gave the start and first instruction. Next, arrows indicate the direction of flow and relationships between the steps. So here we uses different shapes, ovals for starts, rectangular for process, and diamonds for decisions. So that arrows indicates the directions of flows, where it goes, the relation between the steps, first step, second step, third step. And flowcharts can be used to various fields including business, engineering, and programming. So everywhere we use the computers, that for example it is the business purpose or engineering purpose. For example, we have a rough idea. For that rough idea, we use the flowcharts, what it exists and where it problems and where it conditioning true or false like yes or no. So like that we use first the flowcharts for the rough idea what we are existing the solution. So that flowcharts will help you for the programming language. Next, creating a flowchart. So here we using some tools to create a flowcharts, being by identifying the process or problem to be visualized. So when we are trying to say is more impact to the visualized impact to everyone to understand easily, so that the break the process down into manageable steps and determine their order. So it manages the steps to determine the order, what first exists and what second and what third. And next one, use standardized symbols and connect them with arrows to show the flow. So here use the standardized symbol, that is the oval shape is for start, diamond shape is for using if else conditioning formats, and process for rectangle. So these are the standardized symbols, and it connect with the arrows, so where it flow starts and where it goes, next what step to exist. So here we indicates through the arrows. Next, introduction to the algorithm development. An algorithm is a step by step procedure for solving a problem. So here after we developing the flowcharts, we give the algorithm for the computer program. An algorithm is a step by step procedure, for example to exist this step, to after this step to exist, and for solving a problem. Developing an algorithm involves logical thinking and structured planning both. Firstly we implement the logical thinking, for mindly we assuming the what we exist, what the solution is exactly. And next one, for structured planning we follow the flowcharts in paper are structured. Here we apply both algorithm logical thinking and structured planning, both we apply. So logically what they happen, and next structured planning. Algorithms can be expressed in natural language. That natural language is pseudocode or programming language. Programming language is like that, C, Java, XML, HTML, like this. Here we give the diagram, a small diagram. It's a problem definition. First, what we identify the problem definition. Next, problem analysis. So we analyze the problem first, where it start, and it possible the multiple solutions or only single solution, like that. Next, we give the group discussions and give the to select that what is the perfect solution for that problem. Next, algorithm design. So we are designing the process, way to exist, ways to use, and algorithms. Like next we build the flow charts. So first one, what give the condition and the what the process where we start, that's one. So next, implementation. So firstly we are thinking only there only the stop the process. Firstly we try to implement at least the first what we gave the first idea, whether it is good or bad. So firstly we implement that. Next, in that implementation we get some other problems in testing stage or programming stage or designing stage. So clear that all problems, finally we go to the testing, and what is the output is, what's the solution for that problem is we identify. So this circle is performed to the algorithm development. Next, steps in algorithm. So before we discussing that algorithm development, we have a steps. So starts with the clear problem definition. So what's the clear problem definition? We starts with that to understand what needs to be solved. So for problem solution, what we are need. Firstly we understand that the from what is the problem. Next, outline the steps required to reach a solution, ensuring each step is a logical. So each step is too logical. That logical step also is required for that problem solution. And test the algorithm with different inputs to verify its correctness and efficiency. So after we giving the solution, use different types of mentalities of people uses that. For example, any application or website. So for that, we think four sides outside the box of the problem. So test that algorithm with the different inputs to verify its correctness and efficiency. Next, best practices for the algorithm. So best practices ఏంటంటే keep algorithms simple and focused on the problem at hand. So algorithms always must be as simple. So don't be very critical to the when we are designing. So we focus on the only problem. What's the solution? Next, document each step clearly to facilitate understanding and debugging. So we document each step, what will happen the first step and what will happen the next step. Is there any errors or buggings are generated? So those are we document. So then we understand and to clear that the errors. Next, optimize the algorithm for performance without sacrificing clarity. So we not convince our clarity, we cannot compromise our clarity to optimize the algorithm. Next, conclusion and integration. Problem definition, flowcharts, and algorithms are interconnected in a problem solving. So in that problem solving, these are the one flow of to get a problem solution. A strong foundation in these areas enhance the ability to tackle complex challenges. So these are the basic. For example, in literally one word, we say that these are the basics for to any problem solution. We are problem solving. Mastery of these concepts leads to more effective and efficient solutions. Next, here we see some references. Next topic is the summation of set of numbers in this unit 1 also. Next, introduction to the summation is, for example, summation is a process of adding a sequence of numbers to obtain a total. So it is the introduction to summation notation. Here we observe that here is the sigma n I equal to 1, base of I equal to j equal to 1. So these are just rows and columns. It plays a crucial role in various fields such as mathematics, statistics, and finance. So in these we always do the sums to give the two, adding two numbers or multiplying two numbers, three numbers, like. To understanding summation helps in analyzing data and solving problem efficiently. So here also first we analyze the data what they are giving or what we are taking and solve the problems efficiently. Next, definition of a summation. In terms, the summation refers to the operations of adding numbers together. So here summation we added two numbers. It can be represented using the sigma notation. So here we using some computer calculation use the sigma for consists of mathematical expressions. Summation can be finite or infinite depending on the number of terms included. Here we observe that in mathematical summation is the addition of sequence of any kind of numbers called added. Sums result to their sum or total. We here call it a sum or total. In that explanation before we saw the sigma base I equal to 1, j equal to 1, n numbers. So here those explanation we see that I the index of the summation and 1 the lower limit, n is the upper limit. So we start from the 1, the limit is n numbers, so n summations we can do. Sigma, the symbol of the summation, so in that sigma symbol, the summation whole the summation will perform. Xi equal to is a called of element or function. In that x we substitute any different of numbers, alphabets, like this. Next, types of numbers in a summation. So summation we perform a different type of numbers, that is the numerical number, whole numbers, integers, that is a square roots, and decimal numbers. So in these numbers we perform a summation. Summation can involve various types of numbers including integers, rotational numbers and decimals. Each type has its own properties and implications for calculations. To calculate those numbers using the summation formula, identify the type of numbers is a crucial for accurate summation. So that type of here we use the different type of numbers, numerical, whole numbers, integers. In that it is a crucial step to accurate summation that we expect. Next, the summation formula. Here we use some formulas to sum the numbers. The whole numbers are integers, whatever. The sum of finite set of numbers can be calculated using the formulas, that is s equal to a plus b plus c plus so on plus n. So here before we talk about that, the limit is 1 to n numbers. We can add that 1 to n numbers, that is alphabets or numbers, integers, whatever. For a series of consecutive integers, the formula is s equal to n of n plus 1 by 2. Can be used this formula. To understand these formulas simplifies the process of summation significantly. Next, properties of summation. So in this summation we use some properties, that is the alphabets or x, y or numbers. The summation operation is a commutative, meaning its order to addition does not affect the total. So that a commutative property of a addition does not affect the total. For example, here we see that a plus b equal to b plus c. So both a plus b, 4 plus 6, 6 plus 4 is both are same. It is also associated to allotting for the grouping of numbers in any way without changing the result. So here we done what's the is to finally we done the summation, that grouping of numbers in any way, uh, first to last or last to first, in that without changing the result, but it doesn't change the what's the final result. These properties make summation versatile and inductive calculations. Applications of summation. So summation is widely used in a statistics for calculating measures like a mean and variance. So here we identify the summation is what difference between two numbers and addition, sum of total, like this. So the ending value is, here we discussing n, starting value is 1. So xi, that is the function equation what we are substitute the value, that is it is essential in financial calculators such as total revenue or expenses over time, like this. In computer science, summation of algorithms are fundamental for data analysis and programming. So in this summation, for till now we discussing in a mathematical way. So here we discussing in a computer science. This summation is useful on the algorithms for analysis of data, that what we have and what we have to get in programming language. In summation sequence, we often require sum to find total series of terms, that what we have like a b c. So that to find what numbers, what number of data we have. The arithmetic series and geometric series are two common examples for sequence that use summation. Here we use arithmetic and geometric series. Each type of series has its own specific formula for calculating sum. So we calculate the sum, it has a own its specific formula, that here we see that arithmetic sequence formula for n terms is a of n equal to a plus n minus 1 into d. So series formula of the sum of terms, Sn equal to n by 2 to a n minus 1 into d. So here we observe geometric and harmonic. Next, summation techniques. In summation techniques, we have first the index shifting, grouping, order reversal, or series splitting, like this. So firstly we analyze the data, we split the data or to adding the summations, like this. Techniques such as grouping and pairing can simplify the summation process. So we pairing group of numbers or splitting very large number is there, we use a splitting to simplify the summation process. Using mathematical induction can help prove summation formulas. through summation formulas. Advanced techniques include calculus-based approaches for summing infinite series. Next, common mistakes in a summation. One common mistake, miscounting the terms, leading of incorrect totals, or number of summations what we have done, is the failing to apply summation formula can also result in an errors. So here the summation process, what makes the errors to failing to apply the correct summation formula. So, keeping careful track of signs, positive, negatives is essential to during summation. So, here we apply positive values, negative values. So, here the essential during summation is essential to what we are giving signs. Next, the conclusion. The summation is the fundamental and a mathematical skill with widespread applications. In this mastering summation techniques, problem solving abilities in the various disciplines like continuing practice and understanding of concepts will lead to great proficiency in a summation. So first what we have to understand the concepts, that what would perform and what's the summation, what's the formula, where it exists. Here we saw some formulas. Sigma 4n equal to 1 f of n. So here starts with 1, ends with 4. Here we substitute the values. We get the answer. So here we give the conclusion. Here we see some of the references for this the summation of numbers. Okay, thank you.